So this is a competition chessboard that I made recently, and it's solid maple and walnut. It's got a nice inlay on the sides for the letters and numbers. But for most people, this is probably going to be overkill, especially if you just want to get the kids together on a weekend to have a game of checkers. So what I wanted to do in this video is use standard laser grade materials and create a nicely accurate checkerboard and the checkers, and do it for $15 or $20 rather than hundreds of dollars. So if you're interested in finding out how to do that, then stick around. How's it going, everybody? Steve here, and welcome to the shop. Now, on premise, making a checkerboard or a chessboard is pretty simple. You cut out 64 squares, half of them are light, half of them are dark. You lay them down in an alternating fashion, put a frame around them, and glue it all up, and you've got a board. And it should be that simple. But it can't be that simple, can it? If it was, I wouldn't be talking about it in a video. The reality here is if you're using a laser to create a checkerboard, you're going to run into some interesting problems. And in this video, what I'll do is I'll cover some of the things that I ran into, somewhat surprisingly actually, but I'll show you those. I'll show you how I worked around some of these problems. And in the end, hopefully you get a good board out of this. Now, what I won't do in this video is I won't spend a lot of time talking about the design, because at the end of the day, it's really just a bunch of squares for the board and circles for the pieces. I will show you how I laid them out in Lightburn though. All right, so you can use any laser you want for this project. If you have a CO2 laser, that's great, any power. If you have a diode laser, 510, 20 watt laser, you can use that as well. Now the laser I'm choosing to use for this video is the Xtool D1 Pro, in part because I'm a pretty lazy guy and it happens to still be set up from the previous video where I reviewed it. And if you haven't seen that video and you're interested, click the link up above here. But there's a more sinister reason why I want to use the D1 Pro, and that's to highlight a serious design problem that Xtool chose to build into the laser. And it's significant enough that you're going to look at this and go, why does a $1,000 laser have this problem cutting squares? And we'll talk about that. I won't beat up on Xtool too much, because other than this simple limitation that they've chosen to build in, the laser is fantastic, but we'll get going. Anyway, that's enough to get started here. And so round up some material and we'll get going. All right, so the first thing we're going to have to do is establish the accuracy of our laser. And the way I'm going to do that is in Lightburn, I'm just going to create a square that's ultimately going to be the size of the squares on my board, or very close. And I'm going to make them 50 by 50 millimeters. And so that's the square I'm going to use. And to make this easy, I'm going to put a couple of pieces of text here. I'm going to put a y-axis, and we'll shrink that down, and we'll clone it and move it down here, and we'll call this one X. And what that really is doing is what we're going to do is cut cut this square on the laser and see how accurate it is in both directions, and do a calculation to fix that. So the letters I'll make a different color and we'll fill them in. Sure, that looks like a decent power. I'll probably drop the speed down a bit here so we make sure we cut through. This will be very material and laser dependent. So in my case, I chose 600 millimeters per minute at 100% power. I just want to hack this square out. So let me go cut that, and then we'll do a measurement on it. Okay, so I got my square cut out here, and you can see there's an X direction and a Y direction. And if I take my calipers and measure this, and we get fairly accurate, you're going to see it's 49.81 on the x-axis, and on the y it is 49. Let's get this accurate here. 49.67. So clearly that's not 50. More importantly, it's not the same in both directions, so we have to fix that. So here's where things get interesting. We have to do a calibration, because while we said it was 50 by 50 millimeters in Lightburn, in reality it's less than that. So there's a couple of ways to do that. The easy way is to go in Lightburn up to the edit option and select machine settings and click this calibrate axis option, and on the X we asked for 50 millimeters, and what we really got was 49.81, and on the Y-axis we also asked for 50 and we got 49.67. So you can see the calculations there. And now if you have, we'll say quote unquote, a normal laser, you could hit right here and it would save it. But if you have an Xtool D1, Xtool has decided that you can't play with any of the configuration settings in Lightburn. So we're gonna have to do this a different way. And this is honestly a huge problem from an Xtool perspective. If you have an Xtool and you love it like I do, you look at this and you go, this is ridiculous. Why did they do this? And Xtool, if you're listening, please fix this, because there are times when you need to do hyper accurate cutting, and it's just not possible with your laser under normal circumstances. So enough of my soapbox. So there's the settings, and I'm actually going to write these down because for an Xtool D1 we need to do this differently. All right, so assuming you do have a laser like the Xtool D1 where it won't let you change the scale in Lightburn to do the calibration, what I'm going to do is do it manually. And what that really means is, for this square that I created, instead of saying its width is 50, what I'm going to do is bring up my calculator, and to the 50 number that I had originally, I'm going to add the scale adjustment that was calculated in the previous segment, which is 0.381%, because it needs to be 0.381% bigger, and you come up with 50.1905. So what I'm going to do is go up here and change this to 50.19, and we'll round up and say 1, because I don't believe that Lightburn will let me go to 4 digits here, but we'll try it. It rounded it down, oddly enough. So now I'll do the same thing on the Y-axis. So what I'll do is I'll start with the 50 and I'll add 0.664% to it, and that will give me 50.332. So I'll change the Y-axis to 50.332. And I'll go cut this again, and we'll see what the difference is. All right, so I did a few iterations on the calculation to get it just tuned in just right. So if I look at the measurement now, on the X-axis we are 50.02, 50.01, and on the Y-axis we are 50.08. So we're within 1/10 of a millimeter on both sides of the 50, and that should just work out fine. So I'll call that a good calculation, and I'll go out and cut a bunch of squares. All right, so I did all my calculations, and now I know my square. In order to make a 50 by 50 millimeter square, I need to set the width to 50.190 and the height to be 50.312. And when I cut it out, it'll be roughly 50 by 50. So I'll use that square as my reference, and I can get rid of the letters. And so that's the exact size of one square. So what I'll do is I'll just replicate that, and I'll say I want a row of 6 and a height of 6, 6 rows, and we'll click OK. So now we have all of our squares for one color, and I'll do all the cuts in one color first and then the other color. And the reason for that is I'm going to stain one piece of wood. I may stain both, we'll see, but I'll stain one piece of wood before I cut it and get the dark squares. All right, so since half my board is going to be a dark color, I've got to stain some material here, and I'm using this Varathane espresso color. It's just a dark brown. And I'm just going to spread it on my plywood and let it sit for a few minutes, and then give it a good wipe. And what I'll get is a piece of finished material that's the color I want the dark squares on my board to be. And once we do that, then we're ready to cut out a bunch of squares. We'll do the white, obviously, the light color, and then I'll cut the dark color, and we'll have a handful of squares that we can use to assemble our board. Now, because I'm using laser grade 3mm plywood, it's poplar. I believe this one's poplar, not Baltic birch. I need to cut a base board to glue all this onto. So I got a piece of finished one side 1/4 inch plywood here, and I'm just going to cut a square out. Now I want my square to be the width of my border plus added up all of the squares across, which is 8, and 8 times 50 plus another 50 on my border, and it comes out to 500 millimeters. So I'm going to cut a 500 millimeter square, and that will be the thing I glue all of my checkerboard squares and border onto. All right, so we're ready to glue up here. So I have my Titebond 3. You can use any wood glue really, and my backer plate, a roller to spread out some glue, have all my pieces. Now what I'm going to do is, when I mount these, I'm going to put these white squares in the corners, and the reason for that is when I'm ready, I'm going to stack up a second one. So what we'll have is just a little accent in the corner, a little raised piece that'll look something like that when it's done. And should look all right. All right, so we're going to start the glue up here now, and all I'm going to do is squirt out a bunch of glue, and we're going to have to move fairly quickly. We'll have time to work it around, and I'm just going to make it a fairly light coat, not sloppy, so that it's running between the tiles or over the edge. Right, we'll put that to the side. And the first thing we're going to do is start with one side. And we won't press it down too much just yet because we may have to move it around. Okay, now we're going to have to move pretty quickly to lay these down. And you do want to make sure that the grain in both pieces runs the same direction all the way. Maybe you could flip the light ones and the dark ones, which is what I'll do here. So that looks pretty good. Now we can just take a little bit of a damp cloth and wipe off any excess glue. Otherwise we'll just have to sand it off later, and I don't really want to sand if I can avoid it. All right, there we go. Now we can do our last our last pieces here in the corners. And what I'm going to do is, rather than put it on the board, I'm going to put it on the piece of wood, the glue. All right, there we go. Now we can just let it dry. This is the last opportunity to wipe off any glue. So there we go, looking good. Now I may just put a little weight on the corners here to make sure everything stays down, but it should be okay because the plywood underneath will make sure it's flat. So we'll let that dry and we'll see what happens next. All right, the last thing to do here is finish the board with some kind of protection, and I've decided to use this polyacrylic satin. I'll put a couple of coats on, a couple thin coats, and that'll just keep the board from getting marked up or dirty. And I've used polyacrylic for a lot of things. It works really well. So, but you can use anything you want. You could use just mineral oil or linseed oil on it as well. All right, now that we got the board put together, basically finished now, we need some checkers. And the way I did checkers, I'll just pop over here to my screen. I won't show you how I created this because it's really just a bunch of circles, but I picked basically a circle that's 40 millimeters in diameter. I cloned it, then I created another circle inside it that's 25 millimeters in diameter, and I'll show you why this is. And then in the center of that, I put some kind of logo. In my case, it's just my company logo, but you could use anything you want. And when we cut this, it'll be 3 layers. The top layer will be this smaller disc with the logo in it, and it will be glued into the center here. And this will be the middle layer, and then the bottom layer will be this ring. And the reason we're doing that is because in checkers, when you king somebody, you need to stack a couple of checkers up. This will allow you to just interlock them and finish, have a nice job. So that's the checkers. We need a pile of these, and we'll cut those out. Now we have the laborious task of assembling 24 checkers, and they come in 3 pieces. So we'll start with the top part, which is the smaller circle, and I'm just going to put a little bit of glue on the back of it, and I'll use the ring that's on the bottom as the base to get it put in the right place. Now you don't want to obviously smear a whole bunch of glue here, so be conservative. And I'm trying to match up the grain on the top piece with the larger circle. And once it's in place, press it down a bit, and it's ready. And then I just put a bit of glue on the back ring. Again, being conservative, it's a little less important on the back of the checker, but you don't need more glue than necessary. So you'll end up wiping it off otherwise. And once I get the glue on there, just press it all together, make sure it's all lined up, and really that's it. It's ready to go. And finally we have the finished board, and you can see it behind me here. We'll do a little bit of a flyover just to get a close-up. So you can see how the checkers worked out. I did put a bit of polyacrylic on them as well, just to protect those, and there you go, there's the board. It looks pretty good. All right, so hopefully you got a decent checkerboard out of this, and you can have a few games with the family on a weekend sometime. I also hope that you gained a bit more understanding of your laser itself, particularly around the accuracy and calibration. Now, we all have this implicit belief that diode lasers are these deadly accurate devices, and as you saw here in this video, that's simply not the case. So you do have to do a bit of work to fix that error that is there. Otherwise, you just won't get any accurate alignment of squares when you're building your checkerboard. So you know, pay a little attention to that and you'll be fine. You also saw I used the X-Tool D1 here. It has a big limitation in that you can't calibrate it in a permanent way. So you have to do some other tricks to get around that, and we use Lightburn to do a bit of math and solve that problem. But it's not something I would expect in a $1,000 laser. But anyway, we got our board built, and you know, we're ready to go. All right, so before we wind down, I want to take a quick second to plug the channel. I do notice that a lot of people watch videos and they haven't subscribed. So by all means, please click that subscribe button down below. It helps out the channel and helps bring more content and inspires me. So with that, we can wind down here. As always, I'll put a video up in the corner I think you might be interested in. Go watch that and I'll see you over there. Otherwise, get out there, make your world, and I'll see you next time.